In this video, we will continue with geometry, and we are going to solve the variables t, k, y, x, and z in the following diagram using all of the knowledge which we have learned in the previous videos. So in this diagram, we have BF is parallel to CD, and we have the line ABD as a straight line. And we have the line HED also as a straight line. Before we just dive into trying to solve it, remember you do not have to solve the variables alphabetically. You can solve them in any order in which you see them, and you do not have to rush into it. First, look at the sketch. Look at what is given to you. So let us see. We have BC equal to BD, and we have a 48 degrees there, and we have an X there, just by looking at this triangle. Now, before I even go on, I see I can solve X. So let me write it down. X is equal to 48 degrees. And the reason why X is equal to 48 degrees is because the line BC is equal to the line BD. It's an isosceles triangle. Remember, in geometry, we need to state a reason why this is true. Now I'm done with X. If I see what is connected to this triangle, I see it flows to 2y. But there was information given about this line. The information is that the line ABD is straight. Now, if the line ABD is straight and it's connected to this triangle, I see that 2y is the exterior angle of the triangle BCD. So 2y is on the outside of that triangle. So I can find 2y. 2y is equal to x plus 48 degrees. And the reason, the exterior angle of a triangle is equal to the sum of the opposite interior angles. We don't have to write opposite out completely, or interior, or exterior. But the reason is that the exterior angle is equal to the sum of these two. And we know that x is 48. So we can replace x with 48 degrees. And 48 plus 48 is equal to 96 degrees. But that is 2y. Therefore, y is equal to 48 degrees as well, because the sketch was given 2y. But to find y alone, which was the question, I simply need to divide both sides by 2. Now I have a value for y, and I have a value for x. Now, as I continue and I move away from this information, I see z is standing there. But now I notice that z is opposite of 2y. But the angle doesn't look equal. It appears that it's vertically opposite, but it's not. For an angle to be vertically opposite, this line needed to be straightened, and then that angle must be directly opposite it. So we can see that z is not equal to 2y. But what I can see is that z is connected to the line BF. And BF is parallel to the line CD. Now I can see that between z and x, there is a connection point in that line. So z is alternate to x. And therefore, they are equal alternate angles. So z is equal to x. The reason, alternate angles. And the reason why we can use alternate angles is because the line BF, that line, is parallel to CD. But we know that x is equal to 48 degrees. Therefore, z is also 48 degrees. And now we have worked out z. Moving on with the sketch, I'm done with 2y, I'm done with x, I'm done with z, and the next letter that I see is t and 3k. T and 3k are on a straight line, but I don't have one of the values. If I look at t, we can see that t is also connected to a parallel line. And if I find the other parallel line, it's CD. The angle x and 25 together is corresponding to t. So I can find t. And the reason is corresponding angles. I can use corresponding angles because BF is parallel to CD. And we know the value of x is 48 degrees. So 48 plus 25 is 73 degrees. Remember, in angle sizes, once we solve them, we need to show degrees as our solution. So thus far, we have solved x using the properties of an isosceles triangle. We solved 2y as the exterior angle of the triangle. We solved z as alternate angles. And we solved t by combining x and 25 degrees as corresponding angles. Now we can find k. So t, 30, and 3k are on a straight line BF. So I would say t plus 30 degrees plus 3k is equal to 180 degrees. And the reason why this statement is true, they are angles on a straight line. Now I can substitute t with 73 degrees. To find k, I can move the 73 plus 30 to the other side. So 3k is equals to 180 minus 103 degrees, because 73 plus 30 is 103 degrees. So 3k is equal to 77 degrees. And dividing both sides by 3, I find that k is 25.67 degrees. It is okay to find a decimal value as an angle size. Do not think that you made a mistake somewhere. It's just simply when we divided 77 by 3, there was a remainder. So it is okay to have decimal values.